SI minus AC equal to N, which is the observability condition that can be found. Okay. Now let's look at how this condition may not be satisfied. Let's look at condition 1. So if you look at condition 1, we have CACL here, we have CACL here, and we have LA. So in other, to satisfy condition 1, LA needs to belong to the row space of CACL. That's how that condition can be satisfied. So if this condition is not satisfied, obviously the left-hand side is going to be bigger than the right-hand side. Left-hand side is going to be bigger than the right-hand side. So if that's the case, and we want to find an L, we want to increase the rows of L naught to satisfy this condition, we need to somehow increase the rank on the right-hand side and hope that this rank on the left-hand side doesn't increase. So it's kind of a balancing act we need to do. We need to increase this rank and try to make sure that this doesn't increase. And if we want to increase the rank on this side, obviously this L has to come outside of CAC. So it can't, the rows that we want to insert cannot belong to L naught CAC. It has to come from outside. And how can we violate or not satisfy this condition here? Now, assume that we've already satisfied condition 1. We already satisfied condition 1. Then we also want to satisfy this condition here. The way that this, when this condition is not satisfied, the rank on the left-hand side is going to be less than the rank on the right-hand side. That is the only way that can happen. So at some specific values of S in the complex plane, the rank on the left-hand side will be less. I mean, think of the rank SI minus A, C. We want that equal to N for all S elements C. That's the state observability condition. And the rank on the left-hand side is going to be deficient, will drop if the system is not observed. It's the same thing here. This is basically an observability condition. So the way this is, this can be violated if this rank is high, and the way this is violated is if this rank is lower. So we keep that in mind.
So I'll just ask a question.
Yeah, sure.
So if L was non-singular, then would those conditions always be satisfied? Similarly, you said if L is the identity, it's always satisfied.
Yeah.
But if L was just a non-singular matrix.
It may not be satisfied because L is a rectangular matrix. Yeah?
I thought you said L was n by n.
No, L is not. It has n columns.
Oh, okay.
Because it's the number of linear functions we want to estimate.
Right.
So it could be.
But if you increase the number of rows to be equal to n.
We can increase from R to N.
Yes, that's
Yeah,
right.
yeah.
And if you do that and that matrix is non-singular,
That's right.
so it's essentially that you want to estimate all the states because it's just a transformation of the states. Would
Yeah.
that condition be satisfied then?
But if L is equal, if L is non-singular
Yes.
and the system is observable,
Yes.
then these conditions are satisfied.
Right. So it's only the situation when you can't make L non-singular by adding extra rows that those conditions aren't satisfied.
Well, L doesn't necessarily have to be a square matrix, yeah?
But you can add, you can always
Yeah,
add,
yeah,
you
but
can
the
always add rows.
objective is to add the minimum number of rows.
Oh, yeah.
Objective
I
is
was just wondering about your definition of observability. You
Yeah.
didn't say anything about how many rows you should add.
Yeah, it need not say anything about all it's saying is that if there exists an L
Yeah.
which has any dimension.
Actually, there is a misprint. It should be L in R cross N, I think, rather than N cross N.
Okay.
Yeah, that's actually.
Sorry
that's what I thought.
sorry for creating that confusion. Yeah. So I should actually say Q here, and Q being anything from R to N. Okay.
Okay.
Yeah.
But still, you can add rows up till.
Up till N, but the objective is to add the minimum number.
Right, so in terms of this definition though, if
Yeah.
you added rows up to n
Yeah.
to make L non-singular,
Yeah.
then it seems to me that you would then just be trying to estimate all of the states.
That's right. You'll be.
And then assuming that AC was observable.
Yeah, it is
then,
satisfied. Yeah.
then that condition would be satisfied.
That's good.
So it seems like then the only case when it wouldn't be functionally observable is when L0 is not full rank, because then you have
Or the
rows.
system's
L0
unobservable.
is full rank.
Or if the system's unobservable.
Or if
Well, the system is unobservable.
Yeah, that's
I
right.
will give you an example where system is unobservable.
Yeah, sorry,
Right.
yeah, if the
Yeah.
system's unobservable,
Yeah,
then that.
yeah. And of course, L0 will be full rank because we only want to estimate linearly independent. Well, we can assume that.
Yeah, full row rank.
Full row rank, sorry,
Yeah.
full row rank. Yeah, yeah, okay.
Okay.
So, want to define a few terms. T1 tilde is CCA. I don't know why I defined even that, but T2 tilde is CCA and L. So T2 tilde is actually the right-hand side of condition 1. T2 tilde is CCA. And I'll ignore that. T2, put these two square brackets,